Hello everyone. So yesterday we completed the image formation by the convex lens as well as the lens formula and the magnification of lens formula of chapter number 10. Fine. We also did the sign conventions about the lens formula. As I told you earlier that the lens formula sign convention will be same as that of mirror formula. Okay. So today what we are going to do is some of the numericals based on the mirror as well as the lens formula. As I told you earlier, the general formula for mirror is 1 upon V plus 1 upon U is equals to 1 upon F. Fine. If we are having a positive sign in between, then that will be the mirror formula. And if we are having a negative sign in between of that, that is 1 upon V minus 1 upon U is equals to 1 upon F, then that will be our lens formula. Here V is the image distance, U is the object distance and F is the focal length. Fine. So now over here we are also having the two formulas for magnification. The magnification of the mirror formula will be M is equals to H prime upon H is equals to minus V upon U. In the magnification of the mirror formula, we will be having the negative sign over here. We will be having the negative sign over here. Whereas for the magnification of the lens formula, we won't be having any negative sign. So that will be directly H prime upon H is equals to V upon U. H prime upon H is equals to V upon U. So these are the basic formula for which we are going to solve the numericals today. Okay. But first of all, we need to learn the sign conventions for the mirror formula as well as the lens formula. So now, if we are having a convex mirror or a concave mirror as well as the convex lens or a concave lens, what we need to do is, suppose say we are having a concave mirror. Okay, so the concave mirror, the object was always the real and inverted. Fine, the object was always the real and inverted for concave mirror. So for a concave mirror, the object distance will be always negative. Image distance will be always negative as well as the focal length will be always negative. Fine. But for a convex mirror, it will be object distance will be negative, image distance will be positive and focal length will be also positive. So there is a change or a difference between the concave mirror as well as the convex mirror. You should know the difference between the two. In examinations for asking the numericals, they will be asking us that for in a convex mirror, then you should know that the object distance will be negative, rather than that everything will be positive. So over here the object distance will be negative, image distance as well as the focal length will be positive. Fine, I hope you are clear with this. The next thing is about the concave lens and a convex lens. The same things resembles over here for that of mirror. In a concave lens, everything will be negative. Say it is an object distance, then minus U. If it is image distance, minus V, as well as the focal length, that is also minus F. So each and everything is negative for the concave lens as well as the concave mirror. The next thing is about the convex lens. Now, the convex lens is also the same as that of convex mirror. Okay. Except of object distance, everything will be positive. So over here, object distance is minus U, image distance is V, as well as the focal length is F. The focal length is F. Okay. So these are the general rules and regulations for the sign we need to keep in mind for solving a numerical. Okay. So my first question is from this, and this is from your example 10.1 of your textbook chapter number 10. Okay. We are having a convex mirror. The radius of curvature is given over here and the radius of curvature is 3 meters. The object distance is given as 5 meters, but we need to take for a convex mirror it should be negative. So I have to take object distance as minus 5 meter. Then we need to find the image distance as well as the magnification. Okay, I hope you are clear with this. So let us start with the first numerical. So if they have given us radius of curvature as 3 meter, we can write r is equals to 2f. Therefore, f is equals to r upon 2, and that is 3 upon 2. So our focal length becomes 1.5 meters. Okay, so now our focal length has become 1.5 meters. Okay, we are also having the object distance, and that is minus 5 meters. See, for a convex mirror, you need to see over here this table. The object distance should be negative, rather than that everything should be positive. So the mirror formula states that so 1 upon V plus 1 upon U is equals to 1 upon F. Fine. We can substitute the values over here. So that becomes 1 upon V minus 1 upon U. So what is U? That is minus 5. And 1 upon focal length, that is 1.5. Okay, I hope you are clear with this. We need to find what? V, that is the image distance. Then we can shift this minus 1 upon 5 over this side. If you are shifting any numerical signs on the another side of the equal to, then the sign changes. So if we are having just now what is that minus 1 upon 5, we can turn it into plus 1 upon 5. So that becomes 1 upon 1.5 plus 1 upon 5. Okay, I hope you are clear with this. So now we need to take the LCM of this. If you want to take the LCM, you can also remove this point and multiply the tan over here. Okay, so now what becomes? Here we are having 15, here we are having 5. I need to multiply with this 3, and then 1 also gets multiplied by 3. And so we can have 1 upon V is equals to 10 plus 3, base becomes same, and that becomes 15. Okay, so 10 plus 3 upon 15. Now we can write V is equals to 15 upon 13. Okay, so that becomes what? 15 upon 13. So 15 upon 13 is your final answer. We can solve it in a simple form, dividing the 15 by 13. So that becomes 1. 13 remains over here. So 5 minus 3 will be 2. Putting a point over here, and we can write 20. So writing a 20 over here, we can write again 1, and that becomes 13. 7. Then we can again put 0, and that becomes 13 5s are 65, and so we are left with the remainder 5. That will be okay if you don't further solve it. So that the answer will be 1.15. So our V is 1.15. See students, you can see that as I told you that the convex mirror image distance should be positive, and I am getting a positive answer. That means we are right. So we got the 1.15 meters, that is we got image distance. Now what we need to find? We also need to find the magnification. For solving the magnification, we are having a general formula. Fine. For a magnification, the formula is M is equals to minus V upon U. M is equals to minus V upon U. So we can substitute the values of minus V. What was that? Minus 1.15. What was the values of U? That was also a negative. That is minus 5. So we can cancel out the values of minus minus. And so the magnification becomes 1.15 divided by 5. Okay. Now we can solve this. 115 divided by 5. And so that becomes 2s are 10 and 15. So we can multiply it with 3. 5 3s are 15. It cancels out and becomes 0. So, but we were having what? 1.15. So magnification of 2 decimals will be 0.23. So this is the magnification. This is the magnification. For a convex mirror, the image will be what? Virtual and erect. It will be virtual and erect, and the magnification, yes, we need to see the magnification. Fine, that either it is small in size, enlarged, highly enlarged, or a point size. Then we need to compare what? We need to compare the object distance and the image distance. See students, here over you can see that the object distance is 5. The object distance is 5. But what is image distance? Image distance is 1.15. So over here you can see or observe that the object size is more bigger than that of image size. So from this we are clear that image size is smaller than that of object size, and so the size will be small in size. It will be small in size. Fine. I hope you are clear with the first numerical over here. Okay, if you are having any doubts, then you can ask me in the queries. Okay, so this was the mirror formula using convex mirror. So we are done with the convex mirror. Fine. I hope you are clear with this. Okay. You please check this sum once more, and then we will go for the next second sum. Fine. So if you are clear with this, we are moving on to the second sum. Okay, this was for convex mirror. The nature is virtual and erect. The size is small in size. Okay. So let us move on to the next topic, and that is what? The concave mirror. The concave mirror. As I told you earlier, the concave mirror should have everything in the form of negative. That is, the object distance should be negative, the image distance should be negative, as well as the focal length should be negative. Okay. So over here, this is the example number 10.2 of your textual exercise or textbook. Okay. So over here, we have given the object distance, that is 25 centimeter. But as it is a concave mirror, I need to write object distance as minus 25 centimeter. Okay, they have also given us the focal length, that is minus 15 centimeter. See over here you can see the changes. In the first term they have given us the radius of curvature, but now they are giving us what? The focal length. Now the focal length is directly in the form of formula, so we don't need to change anything. We need to directly substitute the values. Fine. So focal length is given, and we need to find the image distance, that is V we need to find. Okay, this is your U, this is your F. Substituting the values for the mirror formula. So what is mirror formula? 1 upon V plus 1 upon U is equals to 1 upon F. So now what happens? Substitute the values of each and everything what you are having. We need to find 1 upon V, that is we need to find the image distance, minus 1 upon 25. Why minus? Because object distance should be negative in the form of concave mirror, is equals to minus 1 upon 15, because focal length should be also negative. Substitute, interchanging these values over this side, shifting, so that becomes plus 1 upon 25 minus 1 upon 15. Okay, I hope you are clear with this. 1 upon V is equals to 1 upon 25 minus 1 upon 15. Okay, so what we can do over here, we can take the LCM of this 25 and 15. We are having anything in common? Yes, 5s are. So 15 5s are is 75, 25 3s are is also 75. So we can multiply it with 3, we can multiply it with 5. I hope you are clear with this. Okay, so we can write 1 upon V, keeping the base same, because 25 3s are 75 and 15 5s are 75. So 3 minus 5 upon 75. So what it becomes? It becomes 1 upon V is equals to minus 2 upon 75. Okay, and so that becomes V is equals to 75 upon minus 2. we need to half the 75 upon 2 so that we can get the final values of V, that is the image distance. And so 75 divided by 2, that is 3, 6, 15. Fine, it is okay. Then 7, 14, keeping a point, 1, 0, and that is 37.5. So answer is minus 37.5 centimeter is your final answer. So the image distance is minus 37.5. As I told you earlier that for a concave mirror, each and everything should be in the form of negative. So here we can see that V is equals to minus 37.5, that is also negative. So we can assume that our answer will be correct. Okay, let us move on to the next thing, and that is the magnification. Now they have also given the height over here, that is h is equals to 4 centimeter. Now we are having two formulas for magnification. M is equals to h prime upon h, E is equals to minus V upon U. So magnification becomes what? We can write only h prime upon h is equals to V upon U. What we need to find? We need to find h prime. And so h prime becomes minus VH upon U. H prime becomes minus VH upon U. So h prime will be what? Minus V. V is what? Minus 37.5. What will be the h? H they have given us the positive height, that is 4 whole upon U. Now what was U? You can check that it is 25 and that was negative, of course. You can remove this minus sign over here, and so you need to multiply 37.5 multiplied by 4. Let us do that. 37.5 multiplied by 4. So 5 4s are 20, 7 4s are 28, 28 plus 2, 30, 4 3s are 12, 12 3s are 12 plus 3, 15. Okay, and so that becomes 150. Okay, because keeping one decimal point over here because of this. So that is 1500. Now we can write h prime is equals to plus 1500. Sorry, not 1500, of course, 150 upon minus 25. So we can cancel this 150 with 25, 6 are, and so our h prime becomes minus 6. H prime becomes minus 6 centimeter. Fine, the h prime becomes minus 6 centimeter. As you know, as you can see over here, students, the height is negative. And according to the sign conventions, if the height is negative, according to the sign conventions, if the height is negative, that is h prime is equals to minus 6 centimeter, that means the image formed is real and inverted. It is real and inverted. So if it is real and inverted, and you can also see that the object height was what? We say 4 centimeter, but the image height has increased, and so we can write that it is enlarged. It is enlarged. Real and inverted, enlarged. So this is our final answer. Okay, so this was for what? The concave mirror. It was for concave mirror. I hope you are clear with this. Okay, you should please check it one more time, and then we will go for the another sum. Okay, I hope you are clear with this. You can go for this. Fine. So let us move on to the third sum, and that is about lens. Okay. Now as I told you that the sign conventions for the lens will be same. What we were having in the concave mirror, that we will be repeating in the concave lens. and what we were having for the convex mirror, that we will be repeating in the concave lens. Okay, so the sign convention is given over here on the right hand side of my board. That is the concave lens, the object distance, the image distance as well as the focal length, everything remains negative. First thing. Next thing is what? That for the convex lens, except object distance, everything is positive. Object distance was always kept on the left hand side according to the sign conventions, and so in each and every case, either it is a mirror or a lens, a convex or a concave, we will always keep it negative. Okay. So going on for the third sum, it is for a concave lens, and so the image distance is given over here, and image distance is minus 10 centimeter. We need to find object distance, and the focal length is given something like minus 15 centimeter. Okay, this is your example number 10.3 in your textbook. Please verify through it. Okay. So now the formula is 1 upon V minus 1 upon U is equals to 1 upon F. So in the first two examples, what we did was 1 upon V plus 1 upon U, because that was the mirror formula, and this will be the lens formula. So now we can substitute the values first. So 1 upon V remains as it is. Now this is minus, and the object distance we need to find. Okay, so we can substitute the values itself. 1 upon V is what? Minus 1 upon 10. Minus 1 upon U is equals to minus 1 upon 15. We can shift these things over here, and so that becomes minus, or we can do minus 1 upon 15 inside, and we will remove this minus 1 upon U this side, and so that becomes 1 upon U positive. Minus 1 upon 10 will remain as it is, but it becomes 1 upon 15. I hope you are clear with this. What I did, minus 1 upon U, I shifted over this side, and so that becomes positive. Minus 1 upon 15 I shifted inside, so that is 1 upon 15, and minus 1 upon 10 is this. Okay, so 1 upon U is equals to, we can take the LCM, yes. This can be multiplied with 3 and this with 2. So this with 2 and this with 3. And so that becomes 2 minus 3 upon 2 1s are 2, minus 1 3s are 3. The 2 minus 3 upon 15 2s are 30. So that is this. Now we need to find 1 upon U. So 1 upon U is equals to minus 1 upon 30. And so you can tell that U will be minus 30 centimeter. See students, if whatever sum you are solving and if they are asking us the object distance, the answer should of course come into the negative form. If it is getting in the positive form, means that is your mistake. Okay, sum is not having any mistake. If the answer is positive, then that will be your mistake. Answer should be compulsory in the form of negative if the object distance is being asked. Okay. So U is equals to minus 30 centimeter. Now we got the U. Now we can also find the magnification. What was the magnification formula? That was M is equals to only V upon U. So M is equals to, what is V? Minus 10. What is U? Minus 30. Minus gets cancelled out. And so M is 1 upon 3. And that is something what we call as 0.333. Okay, so magnification. Now you can see that the object distance is more than that of image distance. Object distance is more than that of image distance, and so the size is small and diminished. Small and diminished. Okay, the size is small and diminished. Okay, I hope you are clear with this. It is small and diminished. Okay, you please go through it once, then we will be solving for the third sum, fourth sum. Okay, clear? I am removing this. So the fourth sum is for the convex lens. The fourth sum is for the convex lens. Okay. And there they have also given us the height. That is the height of the object. H stands for height of the object. H prime stands for height of the image. Okay. Focal length is given 10 centimeter. Object distance is given as minus 15 centimeter. As well as we need to find V, that is the image distance we need to find, and H prime also. So for a convex lens, as I told you that only object distance should be negative, rather than that everything should be positive. So we can write the lens formula such that 1 upon V minus 1 upon U is equals to 1 upon F. Substituting the values of everything, 1 upon V remains as it is. What is minus 1 upon U? U is of course plus, so that becomes minus, minus, so that becomes plus. 1 upon 15 is equals to 1 upon F, that is also 10. I can shift these values over here, and so that becomes 1 upon V is equals to 1 upon 10 minus 1 upon 15. What I need to do? I can take the LCM over here. And so I need to multiply it with 3, and with 15 I need to multiply it with 2 and 2, so that becomes 30. Okay, so 1 upon V will be 3 upon 10 minus 2 upon 10, and so that we can say is bases are same, then 1 upon 10, V will be 10 centimeter. So V will be 10 centimeter. So you can also check that for a convex lens the image distance should be positive, and I am getting the answer positive. That is ID, that is the image distance, V should be positive. I am getting the answer positive. Okay, next thing was what? The magnification we need to solve. For the magnification, formula was M is equals to V upon U, but they have also given us the height, so we also need to write H prime upon H. So H prime upon H is equals to V upon U. We can write H prime is equals to HV divided by U. So H prime is equals to, what is H? That is 2 centimeter they have given us. V is what? 10 they have given us. And what is U? That is negative minus 15. So we can write H prime is equals to 20 divided by minus 15. Let us solve over here. 20 divided by 15, 1s are 15, 5s are, keeping the point and 50, 3, and so that becomes again 15 3s are 45 and 5, so 1.33. So our H prime is what? Minus 1.33. See students, if we are getting the answer minus 1.33, that means it is negative below the x-axis, and so the object will be real and inverted. It will be real and inverted. One more thing, what is the change in size? That the height of the object was 2 centimeter, but now the answer we are getting is 1.33, and so it is small in size. It is small in size, real and inverted and small in size. I hope you are clear with this. Fine, check it out once. First we went to the mirror lens formula, then we went for the magnification, and then the size and the nature of the object. So that is real and inverted, small in size. Real and inverted, small in size. Okay, these sign conventions you need to go through, and today's your homework will be you need to solve all the 4 sums given over here. Fine, thank you.